Yeah.
I'm afraid they're going to ask me.
All right. Let me begin with a word of prayer. All right. I will begin with a word of prayer. Ahem. 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 Dear Father, we thank you for this day. I thank you for these students. Just ask that you'd bless our time together. Help us to just finish this course well, and just as we prepare for the final, help the students to leave no stone uncovered, Lord. In your name I pray, Lord Jesus. Amen. All right, so let's go over the solution to the quiz. No, you can hold on to it. See here for, so you can check your answers as we go. Yes. All right, so I am still collecting it, so I would like to see a correct answer on the quiz by the time I collect it in about 10 minutes. Yes. All right. What's that? I can't hear myself think. Yes. You can correct any mistakes you have and write down the correct solution as you go if you want. What's that? You've been able to solve number 1 since yesterday? Oh, good. All right, so let's do number 1. So we start by writing y is equal to 3x minus 2 over 2x plus 8. And then we just want to solve for x. All right, so I multiply by the denominator. I get 2x plus 8 times y is equal to 3x minus 2. Then we multiply this out. We get 2xy plus 8y is equal to 3x minus 2. Now I want all my x's to be on the same side. So let's see here. That's going to give me 2xy minus 3x is equal to minus 8y minus 2. Of course, you could move the x's to the other side. I mean, like, there's a couple different ways you could do this, but this is how I'm doing it. Factor x out. We've got 2y minus 3. And then divide, we get x equals 2 minus 8y minus 2 divided by 2y minus 3. And that is the formula right there for f inverse of y. Of course, can you guys, what's another way this might look? Maybe you got f inverse of y equals to, 8y plus 2 divided by 3 minus 2y. This would also be correct. You see, the difference is I just absorbed the minus and rewrote the difference. If you did the algebra a slightly different way, you might have got that for your answer. Do we all understand? I mean, yeah, either boxed equation is correct. Yeah. Question. Now I didn't ask this, but let's ask this question. What's the range of this function? You guys tell me. What would the range of this function be? It would be equal to the domain of the inverse function, right? So what's the domain? What's this? Well, look at this formula down here, right? That makes sense provided what? 2y minus 3 is not equal to 0, right? Which is to say that y is not equal to what? 3 over 2. So this tells me that the range of f is actually equal to minus infinity to 3 halves, not included, union with 3 halves not included, to infinity. So there you go. That would be the range. Are we good? Yep. No? What?
So would we just get credit for finding the formula but not?
Yeah, you don't have to write the red part down if you don't want to.
Okay.
I am merely explaining another possible way the question could appear on the final. Yeah.
Okay.
I mean, that was in the homework, right? So I figure while we're at it, let's see that. Number 2. We start by writing y equals to the formula for f of x, right? And then what's my next move? Yeah, I want to solve for what? I want to solve for x. Move 3 to the other side. That's a good idea. So y minus 3 is twice the log of... Oh man, it's getting worse. Shirt may not be good for throwing. So I got to divide by 2. Y minus 3 over 2 is equal to log base 7 of 3x minus 7. Then exponentiate both sides, right? Base 7. So this tells me that 7 to the y minus 3 over 2 is equal to 3x minus 7. Then what? We want to solve for x, right? So add 7 to both sides. We have 3x is equal to 7 to the y minus 3 over 2 plus 7. So finally x is 1/3 7 to the y minus 3 over 2 plus 7. And there you go. That's your f inverse of y. I guess we could ask the question, what's the range of the inverse function here? Again, you don't need to write this part down if you don't want to, but I think it's an interesting question to ask. What is the range? What's the range of the inverse function? Can you guys tell me? I mean, I suppose you could figure it out by looking at the formula and thinking through it. Yeah? Nope. Nope. The range of the inverse function will not be everything. See, the range of the function, the range of the inverse function will be the domain of the original function. And the domain of the original function is not everything. The domain, so for x to be in domain of f, we need 3x minus 7 to be greater than 0, which means 3x has to be greater than 7, which means x has to be greater than 7/3. So in fact, the range of f inverse is precisely 7/3 not included all the way to infinity. Which you could kind of see from this formula if you thought about it for a little bit. I think. If you, well, I'm not entirely convinced of that actually. Huh. Huh. Okay. Yeah. As y gets really negative, this becomes super tiny, right? So as y goes to minus infinity, this term drops out to 0, and you're just left with 7/3. It never gets there though. When y equals to 3, this is equal to 8/3, for example. Anyway, does that make sense? So the strategy is the same. If you're finding the formula for the inverse function, you start by writing y equals f of x, and then you solve for x using laws of algebra that we've talked about this semester. What's next here? Number 3, how should we do this one? This is obviously a what? This is a review question, right? Is this on the final? Yes, this kind of thing is on the final. So you said I should do what? I should figure... Oh, did we move the camera? Did we move the camera over? Okay, cool. All right, good, good, good. What did you say? I should what? Figure out what the critical numbers are? Yes, agreed. So this is actually x minus 1 times x plus 9 times x minus 9, right? Because that factors. And then you got 2x plus 3 downstairs, x plus 8, right? So we're trying to solve this. What are my critical numbers? Let's put them in 2 different buckets. Let's put them from the numerator. Let's talk about the denominator ones, right? Because you should keep in mind which are which, because if your critical number is in the denominator, that cannot be included in the solution set, right? Because that means there's division by 0. We should never put those into the solution set. That's the thing we saw over and over again, right? So the numerator, critical numbers are 1, 9 and minus 9, right? Denominator, your critical numbers are, well, the easy one's minus 8, right? What else? Negative 3/2, very good. So we need to make a number line. We got to put these in the order that they come to us. The first one is minus 9, if we're reading left to right. And then you got your minus 8. What's up next? Minus 3/2, also known as minus 1.5, right? And then what? Then 1, and then 9, right? And I don't care about the scale. And let me call this thing f of x just for the sake of giving it a name. All right. And then I need to come up with the sign chart here, right? I should document where it's positive, where it's negative. So what goes on here? What I usually do, either plug 0 in and see how that goes, or I think about plugging a really big number in, see how that goes. I'll start with a really big number. If I plug in 10, what happens? Positive, 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 positive. It's all positives, right? So it starts out, excuse me, plus, like that. And then every single one of these factors is linear, right? It's just odd. There's going to be a sign flip at every single one. There's no repeated, there's no bouncing in this. So it goes plus, minus on each critical number. And the solution to this horrible problem is what? Oh, hold on a second. So you said I include the 9? Minus 9? Yeah, include minus 9 because it makes it 0. That's okay, right? And then minus 8, what?
It's not included.
Not included, so we do the curly parenthesis rather than square bracket. And then union what?
Union not including negative 3 over 2. 2 including 1.
Okay.
Union including 9.
There we go. Yeah, that would be the solution set using interval notation. So there will certainly be problems like this on the final, right? You need to understand the number line concept and how we use the number line to solve inequalities, right? The key idea is that the function or expression we're looking at can only change from positive to negative at critical numbers. So if we can categorize where it's positive and negative in each subcase, why are there fruit flies in here? Then we have the whole story. All right. Okay. Yep. Oh, no, okay, cool. How about this one? Number 4, f of x, 3x squared plus 7x minus 1. What do we want to do here? To find the vertex of the graph, how do we do that? we can factor it, right? Now, you guys, I let you have 3 pages of notes for the final, right? Somewhere on these 3 pages of notes, you should just have formulas for the vertex of a parabola, right? I derived formulas for the vertex of a parabola at some point. I'm not sure I remember them with absolute certainty, but I could work them out. For example, I can tell you this. The vertex is at h comma k, and h is equal to minus b over 2a. Now, b is, in this problem, minus 7, and so I get minus 7, and a is 3, so minus 7/6. That's the x coordinate of where the vertex is. How do I figure out the y coordinate? I can do f of minus 7 over 6. So that's 3 times minus 7 over 6 plus 7 times minus 7 over 6 minus 1. And of course we should clean this up, right? That wouldn't be an acceptable way to leave your answer. You should clean it up. Don't be like my physics students who can't be bothered to calculate anything and just leave me these messes of unintelligible 10 to the minus 11th times 10 to the first times 2 divided by pi. Like, that is not an answer. Like, give me a decimal, dude. Anyway, if you know any of them, tell them to straighten up and fly right. Their final's Thursday. Anyway, yes?
Is the first, like, 3 running accent, is that logical squared?
Oh, yes, thank you. That would have soon been a problem. Was that it? Okay, so 3 times parentheses 7 over 6, square that guy, minus 49 divided by 6, minus 1. My calculator says that that is minus 61 over 12, right? So allegedly, if you believe my, I mean, this I can remember that, like figuring out, I do remember that the, you know, the x coordinate for the vertex is minus b over 2a. This is something I know. It's something that should be on your formula sheet, along with a sentence to explain what it means, right? If you just have formulas without like a reminder for yourself in words of what it means, those formulas aren't particularly useful, right? What would be most useful is if you have the formula and like a little example. Here's a formula, you know, here is the vertex. That would be best for you in terms of just having a safety net for this kind of problem on your final, right? So the vertex is at, where was it? Minus 7/6. And apparently minus 61 over 12. So what does this all mean? This graph, what's the graph of this thing look like?
So you do minus 1.
Oh, minus 1, and what's that?
That's the y-intercept.
Y-intercept is minus 1, very good. I'm going to put that into decimal form because that'll help us make a graph which is not, you know, nuts. So this is minus 1.16-ish, and 61 over 12 is about 5. It's 5.08. Okay, so that's where the vertex is at. Well, that feels wrong. How can that be?
Would it be minus?
Yeah, sure, would be minus 1.
Oh, okay, minus. Oh, thank you. It was blowing my mind for a second there. Okay, so minus. So this is the y-intercept is at minus 1. The vertex is about minus 1 over, but about 5 down. So here-ish. Right? And so does this parabola have x-intercepts?
Yes.
Sure does. Are they pretty? No, they're not. I don't think anyway. Excuse me. So this is the graph of this thing, roughly speaking. Right? There's a graph. Now, you notice I did not have to complete the square to figure this out. I know it goes against my larger purposes of preaching about completing the square, but if you're really, really bad at it and you're still bad at it, you probably should have a backup plan, right? This is it. You don't, but you still do need to plug in numbers into the formula for the function and meaningfully calculate them carefully, right? You have to do that, otherwise you won't be able to get this problem right. So my question then is, well, because we found the vertex, part A, right? What's the range? The range of f is, I heard, minus 61 over 12 to positive infinity, right? So that is the answer for part B, because those are all the y values that we see that the graph attains, right? All of those y values are attained by the graph. All right. You know I can't stop myself. I need to show you how to solve this problem with completing the square, right? You knew I was going to do it. You knew I was going to do it, right? I would argue that completing the square might not be the smartest way to do this one, but it is a way. This particular problem, problem 4, it's just fundamentally ugly, right? It's ugly. It's hideous. I don't know if it's hideous, but it's, I don't know. All right, so if I'm going to complete the square on something like this, the first thing I do is I factor the 3 out, factor the leading coefficient out, like this. So that puts a 7 over 3 here, and a 1/3 over there. So factored the 3 out. Now that I've done that, I can complete the square as I usually do. I take half of the coefficient of x, in this case this guy, right? And so I do x. What's half of 7/3? Well, it's 7/6. So I do 7/6 quantity squared. But then to be fair, I have to subtract 7 over 6 quantity squared. And I still have that minus 1/3 there. Yep. So this gives me 3 times x plus 7 over 6 squared. And then I'm going to use my calculator to make that pretty. What I'm looking at there is 49 over 36 minus 1/3. So that probably is, that's 61 over 36 actually, so minus 61 over 36. Now it depends on what you're after here, right? If you want to see the vertex form, we just multiply this out. We've got 3 times x plus 7 over 6 quantity squared minus 61 over 12. How did I get that? When I multiply 3 times 61 over 36, I have 3 over 36, which is 1 over 12, right? So what are we looking at here? Well, now we're looking at the so-called vertex form of the parabola, right? This we can think of as a times x minus h quantity squared plus k. So this you can identify. H is minus 7 over 6, and the k for the vertex is minus 61 over 12, which is of course what we found from that other approach over there, which is better. I think the first approach is better for this problem, personally, but it's important for you to know about both. What are the x-intercepts here? Well, I can come back up to this step right here, right? And I can factor. I can do factor just like this. This is x plus 7 over 6 minus the square root of 61 over 36 times x plus 7 over 6 plus the square root of 61 over 36. Of course, that could be simplified, but there you go. That's how this is how we can factor this quadratic. Right? So completing the square simultaneously gives me access to the vertex form by that multiplication or the factoring by the other step. Let me just make another example up here. Suppose you've got y is equal to 12 times x plus 2 squared minus 71. Where's the vertex? Can you sketch a graph of this parabola without breaking a sweat? Where's the vertex?
Minus 71.
So the vertex is wherever the squared thing becomes 0. That's the smallest value that it takes, right? So if I put x equals to minus 2, this is gone. So it's at minus 2. And when you plug in minus 2, what do you get? You get y equals to minus 71. So the vertex here is at minus 2, minus 71.
The vertex is not just HK.
Well, this is, notice that the pattern is x minus h squared plus k. So when we're doing pattern matching, we have to look for a subtraction. So to see x plus 2 as a subtraction, it's x plus 2 is x minus a minus 2. That's the way we have to think about it as we compare this and that. I think of it this.
I think it's generally safe to say the vertex is the opposite of H and then K.
Well, it depends on what you mean by it. The vertex is the value, where is the vertex? It's wherever you can make the value for the parabola, the formula, either the smallest or the largest, because it's at the vertex. It's either at the top of the mountain or the bottom of the valley. It's going to be what makes the squared term be 0. So whatever it takes to make that happen, if it's x plus 2, it takes minus 2, right? If it was x minus 13 here, you'd have to put x equal to 13. So I think that's what you're saying, but yeah. Okay, guys, any other questions? So you can go ahead and turn in your quiz. I will try to remember to give these back to you at the final. Thank you, thank you.
I really don't want to fail this class. I think I need like 100.
For an X?
I can get a B.
Uh-oh. All right. Now, I should mention, guys, I've gotten a little bit behind at this point in the semester, so I don't have the solution for mission 3 written up yet, but that's like what I'm doing this afternoon, so hopefully I'll have the solution posted later tonight. So you can check your work. Obviously, I have not checked your work very carefully. You can appreciate that, yeah. It's funny how students usually appreciate my lack of detail in grading. We're all humans, as far as I know. Let's see here. Well, did you say you identify as salad? What?
I identify as a taco truck.
A taco truck? This is very abstract.
Really good right now.
Very abstract. Let's see here.
You want me to have the camera so we don't need the whiteboard?
Oh yeah, you can angle it up to the screen. It's fine. Okay, so what did I tell you guys about the final so far? I can't remember.
3 pages of notes.
3 pages of notes. I do all the work for you. What is it? No.
You can place a test grade with your final.
So to be clear, the final exam is not a group project. It has to be done individually without the help of others. The use of photomath is prohibited. What else can I tell you?
Are we allowed to borrow a calculator?
You may borrow a calculator from the math department. That is true. Other questions? I am having trouble finding the course. Ah, here it is. I would encourage you to, look at. I would encourage you to look at the solutions to the quizzes, to the tests, to the homework. The final is comprehensive. So. C's get degrees. Them's fighting words. Let's see here. Facts, yeah. All right, let me tell you the story of the final. No, I'm just telling you the problems that were on, like, I think this is the final I gave last semester. I'll just tell you the kind of problems I have on it, all right? Like problem 1, it's got A, B, C, D, E, F, all factoring. Every different kind of factoring you can imagine, it's there. Let's see here. Problem 2, I got some inequalities. One's just a plain linear one. You know what I mean by linear inequality? Yeah, well, not even that. It's something like this, and this is not it, but I'm just saying this could be it. Something like that, okay? Like a linear inequality, very boring, the first thing. The next inequality involves absolute value. For part B, you have to solve an inequality involving absolute value, right? You should remember the story for the inequality with absolute value is very different if it's less than versus greater than, right? Like the way we solved those inequalities was very different. You need to review that. Then part C is an inequality that's involving a rational function. It's a less complicated version of like the thing I just covered up here we just had for part 3 on the quiz just now, all right? Problem 3. I ask you to solve, it's got a part A and a part B. I ask you to find the solutions, real or complex, of the following equations. If I ask you to find the solutions, real or complex, of the following equations, what kind of equations must they be? They must be polynomial equations, but probably they're quadratic, right? Because the only thing we've really looked at finding the complex solution of is a quadratic equation. So they're either, what are your methods to solve a quadratic equation? Let's review. Factoring, right? First of all, factoring. If you can factor it, great, you're good to go. But also, if it's written as a square, right? So like if your equation is something like, let's say 2x minus 1 squared equals to 7, how do you solve that equation? Yeah, I mean, so I would use the square root property, right? So this tells me 2x minus 1 is plus or minus the square root of 7, which tells me 2x is equal to 1 plus or minus root 7, which tells me that x is equal to 1 plus or minus the square root of 7 divided by 2. So like,
We'll have to replug.
So, what's that?
We'll have to replug for extraneous solutions.
Not for this one, but that is something to watch out for later, yeah. So my point is, if it's factored, great. You can use the product of two numbers is 0 only if one or both of the numbers are 0, right? Factoring, that's one way we solve equations. The square root property is really nice if your equation's already a square, right? But of course, if it's not already a square, we can complete the square to make it into a square and use this as well. How would we have gotten a complex solution in this kind of scenario? Well, if instead of having a 7, I had a minus 7, then I would get a complex solution here, right? We talked about those. All right, problem 4. Part A is like a rational equation. Solve a rational equation. What's a rational equation? Do you guys remember these? Things like And again, this is not the problem on the final, but this is the kind of thing. You know, 3 plus x over 2 minus x equals to 4, or maybe 1 over x plus 2 minus 3 over x squared minus 4 equal to 2 over x. I mean, I'm just making these up. These could be horrible. Don't try to solve these. Do not try to solve these. Do you understand me? Do not try to solve these. I repeat, do not try to solve these. You have many examples in your homework and in the quizzes and in the tests. You should look at those. All right?
Whoa, this is a weird fraction you said. Why'd you ask us to solve this?
And then the next equation is an algebraic equation. So there's a square root involved. You know, we talked about things like that, right? Like equations like, I don't know, x plus the square root of x minus 1 equals to the square root of x plus 2, something like that. You know, how do you solve this kind of equation? Or maybe there's just one square root, you know. The general way to solve these is you isolate the radical, square it, and then if there's another radical, isolate it, square it again, and so forth.
Can you do like square both sides in that kind of situation? Just like
It's gonna have to be a two-step process, that kind of thing. Problem 5, I have, here's 4 graphs, match the 4 equations, A, B, C, D kind of thing. Problem 6, I say find the coordinates of the vertex of a parabola. And the formula is not as ugly as what I just did for the quiz. Problem 7, I have here's a rational function, find the x-intercept, the vertical asymptote, and the hole in the graph. You might remember that problem from your mission 3, right? I think mission. It may also be in. It may also be in mission 2. You might be right. Find the center and radius of the circle with equation blah, 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 blah. All right, so you know how to remember we completed the square in x and y to figure out circle equations. There's that kind of problem there.
Mr. Cook, we live in America. You don't get to self-censor. You can say everything on the test.
I can say whatever I want in America. So I could, for example, if you chose to say have pronouns, I could refer to you by your biological pronoun and not the one you chose. That I would be well within my rights there. No one would fire me from my job or something like that because we have freedom of speech in America. Yeah, sure we do.
You just can't incite violence. So if you told us to go like burn down the math department, that might be wrong.
See, but inciting illogical action in people, we're living in a society with a bunch of people driving around in cars with masks on. So like, I don't know, you know, what does it take to incite violence? I don't know. All right, I gotta get back on track here. This problem 9, I give you the graph of a polynomial and I say find the formula. I noticed a lot of you guys left that blank on mission 3. Not a good pattern. That's not a hard problem. Photomath not solve that one? What's that? No, what? You solved that one. No, not everybody didn't solve it, but of the people who didn't solve problems, I noticed that the one that, here's a picture, here's a graph. Yeah. So here, let me just make up one. If my graph looks like this, bounce, cross, bounce, like that, and this is at -3, this is at -1, and this is at 4, a formula for this would look something like a times x minus x plus 3, quantity squared, times x plus 1, times x minus 4 squared. That will do it. You want to bounce, you want to cross, you want to bounce again. And you can select a to be whatever you need it to be to fit the other piece of data which is given, typically a y-intercept.
There was a question exactly like that on the second mission.
Uh-huh.
And it was just a different leading coefficient. The one on the
I
mission was
I am you know, a creature of limited imagination, so it, you know. The next is a log equation. All right, it's a logarithmic equation, solve for x.
How many parts are on the
It doesn't matter. I mean, I'm making you guys a new final, so this is just what happened last semester.
What's like the ballpark?
9 pages?
9 pages?
Yeah.
Front and back or front?
It's just front page.
You know, Mr. Cook.
Yeah, I don't do,
You don't do it that dirty.
I don't like double-sided grading. Besides, the highest calling for a tree is to give its life to make a math assignment.
That is an opinion right there.
It is. It's an opinion which I hold. It's also correct.
The opinion.
It's a correct opinion.
Any opinion you correct?
This one is. Let's see here. So, next one, I give a quartic polynomial, and I give a quadratic factor, possible factor. I say calculate f of x over g of x by long division of polynomials and answer the question. So what happens if you have two polynomials and you divide one by the other? How do you decide whether or not one's a factor? Well, if you do the long division, right, and the remainder is 0, it's a factor, right? If the remainder is non-zero, it's not a factor. Correct? So moving on here, problem 12 is a equation involving logs. Now this is one where you would need to check on whether or not the solution is extraneous.